So what is a complex fraction? Well, it sounds hard, right? Complex, but it's really a fraction inside a fraction, or a fraction made up of fractions. So we want to remember that the fraction bar really means divide. So if I have 1/2 divided by 2/3, we know this is the same thing as 1/2 times 3/2. Remember our keep, change, flip. But when you have multiple fractions inside fractions, you're going to want to follow these steps. So you're going to want to first find our good friend, the LCD. So in this number 2, the LCD looks like 6. Then we're going to multiply each fraction by the LCD. And what we're really doing is we're really multiplying the entire numerator and entire denominator by the LCD, right? So, and then that that's like basically like multiplying by 1, right? 6 over 6 is just 1. But then that 6 gets distributed to each of those. So 1/2 of 6 is 3, 1/3 of 6 is 2. 7/6 times 6 is 7. And then we have our final answer of 5/7. So after we've multiplied each thing by the LCD, we're just going to simplify. So here the LCD would be 14. Now some people like to just kind of distribute that as you go and multiply it by each term. So it gives me 14y minus 7, 14y minus 2. And I can't cancel the 14s. I'm just done. Right? Great. Okay. So moving on to some harder ones. Now the LCD here looks like x squared. It's up to you if you want to distribute in your head or you want to write it all 4 times. So if I distribute this, I get x squared minus x in the numerator, x cubed minus 1 in the denominator. Now this doesn't happen very often anymore where we see this x cubed minus 1. Remember that a minus b, a squared plus ab plus b squared thing? So you can actually then reduce that. There you go. Here our least common denominator is a, so I have 2a minus 3 over 5a plus 1, and I'm done. This one scares people with the negative exponent, but you're just going to rewrite it. 2 over x, 3 plus 1 over x. If you're using different colors, I think it helps. Like I'm going to multiply each thing by my LCD, which is x. I get x plus 2 over 3x plus 1. So your answer is a fraction. So you're simplifying a complex fraction into a regular fraction. Here the least common denominator is ab. That gives me b plus a over a squared minus b squared. A squared minus b squared can factor a minus b, a plus b. A plus b and b plus a, that's the same thing. So I have 1 over a minus b. Here I've got, again, ab, so ab, 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 ab. 3ab minus 3a squared over ab squared minus b squared. Now that one can also factor 3a times b minus a, and then the denominator is b squared times a minus 1. Didn't allow anything to cancel, so technically either answer is correct. All right, x squared here is x minus 5, x plus 2. So we're going to make each one multiply by x minus 5, x plus 2, x minus 5, x plus 2. And yeah, it's annoying to write it all these times, but then you get to do the fun crossing out, right? So here the x minus 5's cross out if I distribute the 4, 4x plus 8. The x plus 2's cross out if I distribute the 2, 2x minus 10. Everything crosses out here, I get 2x, and those cancel out, and I get 3x plus 6. So here we're going to just combine everything, 6x minus 2, 5x plus 6. And I guess you could pull a 2 out of the top, but you don't need to because it wouldn't allow anything to cancel. So that's it, complex fractions.